At 3:47 a.m., somewhere over the contested skies of eastern Ukraine, a signal vanished. One moment, the encrypted data link between a Ukrainian ground control station and a long-range strike drone was humming with clean telemetry. Altitude, heading, GPS lock, target coordinates, all streaming in perfect sync across a hardened frequency. The next moment, nothing. The screen inside a cramped, blacked-out command vehicle flickered once, stuttered, and then filled with static. The operator's hands froze over the controls. Somewhere out in the freezing darkness, traveling at over 200 kilometers per hour, a weapon worth less than a used sedan was now flying blind. Or so the Russians believed. 14 seconds earlier, a Russian Krasuka-4 electronic warfare system had activated from a concealed position just south of the Donetsk front line. Its massive antenna array, mounted on a six-wheeled BAZ chassis, had been tracking the drone's signal signature for nearly 90 seconds, waiting for the optimal window to strike. The system pumped out a wall of directed electromagnetic energy, flooding the frequency band with enough noise to drown out any command signal within a 40-kilometer radius. The operators inside the Krasuka's armored cabin watched their displays with satisfaction. The drone's telemetry blip disappeared from their intercept screen. In their assessment, the threat had been neutralized. The weapon was now a piece of unguided debris, destined to tumble out of the sky and crash harmlessly into a frozen field. They were wrong. To understand why that assumption was fatally flawed, you need to understand the arms race that has been raging silently over Ukraine's electromagnetic spectrum since the first months of the full-scale invasion. This is not a war fought only with shells and steel. It is a war fought with signals, frequencies, algorithms, and the ability to adapt faster than your enemy can react. And in this domain, Ukraine has been rewriting the rules of modern warfare with a speed that has stunned military analysts around the world. When Russia launched its full-scale invasion in February 2022, it brought with it what was considered one of the most advanced electronic warfare arsenals on the planet. Systems like the Krasuka-4, the Zhetel, the Lear-3, and the infamous Pol-21 GPS denial network were designed to dominate the electromagnetic battlefield. These were not experimental prototypes. They were mature, battle-tested platforms that had been deployed in Syria, proven in Crimea, and refined over years of development. Russian military doctrine placed electronic warfare at the center of its operational planning. The idea was simple and devastating: blind your enemy's communications, jam their drones, spoof their GPS signals, and render their precision-guided weapons useless before they ever reach their target. On paper, it was an impenetrable shield, and for a time, it worked. In the early months of the invasion, Ukrainian forces experienced catastrophic losses in their drone fleet. Commercial, off-the-shelf quadcopters, the kind you could buy from a consumer electronics store, were being knocked out of the sky at alarming rates. GPS signals were corrupted, dished video feeds cut to black mid-flight, control links severed without warning. Russian electronic warfare units positioned along the front lines created what some NATO analysts described as the most contested electromagnetic environment since the Second World War. Ukrainian operators would launch reconnaissance drones and watch them spiral out of control within minutes. Strike missions were aborted, intelligence dried up, the invisible wall seemed unbreakable. But Ukraine did something that no military planning model predicted. Instead of trying to match Russia's electronic warfare capability with equivalent systems, a process that would take years and billions of dollars, Ukraine turned to its tech sector. Software engineers, many of them veterans of the country's booming IT industry, began working directly with frontline units. They didn't approach the problem like defense contractors. They approached it like startup founders debugging a product in real time, with the battlefield as their testing environment and survival as the only acceptable outcome. The first breakthrough came in signal architecture. Early Ukrainian drones relied on standard commercial frequency hopping protocols, the kind used in civilian Wi-Fi routers and consumer RC aircraft. These were predictable. Russian electronic warfare systems could identify the hopping pattern, lock onto the control frequency, and jam it with targeted noise. The solution was radical. Ukrainian engineers developed proprietary waveforms that changed not just frequency, but modulation type, power output, and timing intervals, all simultaneously, all unpredictably. Imagine a conversation where every word is spoken in a different language, at a different volume, from a different location. That is what the new signal architecture looked like to Russian intercept systems. Instead of tracking a single moving target across a frequency band, the Russian jammers were suddenly trying to hit a ghost that existed everywhere and nowhere at once. But the real game changer went deeper than signal resilience. Ukrainian developers began embedding autonomous navigation modules into their strike drones, systems that could operate entirely without any external signal. No GPS, no ground control link, no satellite communication, nothing for a jammer to target. The drone would receive its mission parameters before launch, lock in a target coordinate, compute an inertial navigation solution, and then fly the entire attack profile using only its onboard sensors: accelerometers, gyroscopes, barometric altimeters, machine vision algorithms comparing terrain features against preloaded satellite imagery. The drone became its own pilot, its own navigator, its own targeting computer. And when a Russian electronic warfare system tried to jam it, there was simply nothing to jam. This is exactly what happened at 3:47 a.m. over eastern Ukraine. The drone that the Krasuka 4 crew believed they had neutralized was not relying on its ground control link for navigation. The link was active, yes, streaming telemetry back to the operators and receiving minor course corrections. But the moment the signal was severed, the drone's autonomous flight controller activated seamlessly. There was no transition delay, no system reboot, no confused circling while it searched for a signal. The onboard processor simply recognized the loss of external input, confirmed its last known position against its inertial reference, cross-checked with its terrain matching algorithm, and continued flying toward the target on its pre-programmed route. The jamming didn't disable the drone, it simply made the drone quieter. And quieter, in this context, meant more dangerous. With its data link severed, the drone stopped transmitting. Its electromagnetic signature dropped to nearly zero. The very system designed to protect the Russian position had just made the incoming weapon invisible to passive detection. The Krasuka 4 had effectively jammed the drone's transponder, not its brain. The weapon was still flying, still navigating, still closing the distance at over 200 kilometers per hour. And now it was doing so in total electronic silence. Inside the command vehicle, 17 kilometers behind the front line, the Ukrainian operators watched the telemetry freeze on their last received data point. They knew the drill. The drone's blue icon on the screen stopped updating, but no one reached for the abort protocol. There was no abort to execute. The drone was in autonomous terminal mode. Everything from this point forward was between the weapon and its target. One operator glanced at the mission clock. Based on the last known speed and distance to target, impact was approximately 4 minutes and 12 seconds away. He leaned back in his chair, pulled off his headset, and exhaled slowly into the cold air of the vehicle. There was nothing left to do but wait.
Well, what the Russian electronic warfare team did not know, could not have known, was that the target coordinates loaded into the drone before launch were not a random grid reference on a map. They were the precise geolocation of their own Krasuka 4 system. Ukrainian signals intelligence units had been tracking the system's electromagnetic emissions for 11 days. Every time the Krasuka activated, its powerful radar emissions created a detectable signature. A signature that Ukrainian ELINT platforms, some of them modified commercial drones carrying software-defined radios, had been quietly cataloging. Frequency, duration, power level, bearing. Cross-referenced with satellite imagery and ground-based sensor data, the Krasuka's position had been fixed to within a 15-meter radius. The very act of jamming had become the system's death warrant. It was a textbook case of a missions discipline failure, a principle that every electronic warfare operator is taught in training.
But that becomes almost impossible to maintain when your entire purpose is to radiate energy. The Krasuka 4 existed to broadcast, and in broadcasting, it painted a target on itself that no amount of camouflage netting or repositioning could erase. Ukrainian intelligence did not need to break any encryption. They did not need a spy inside the Russian unit. They simply needed to listen. The Krasuka told them everything. 3 minutes and 41 seconds after the jamming began, the drone crossed into the terminal approach phase. Its altitude dropped sharply as the terrain-matching algorithm guided it through a shallow valley approach, and using the natural contours of the landscape to avoid any remaining radar coverage. The machine vision system compared the terrain below against its stored reference imagery, making micro-adjustments to its flight path with a precision that no human pilot could match at this speed and altitude. The drone was now flying at less than 30 meters above the frozen ground, threading between tree lines and power transmission towers that appeared as ghostly outlines in its infrared sensor array. At the Russian electronic warfare position, the crew had already logged the successful jamming event and moved on to scanning for new threats. The Krasuka 4's massive antenna array rotated slowly, sweeping the sky for fresh electromagnetic signatures. The system was operating exactly as designed. Its operators had no reason to suspect that a weapon was inbound. Their radar warning receivers were silent, no missile launch signatures, no incoming artillery radar profiles. The electromagnetic spectrum around their position was clean. In the doctrine they had trained under, a jammed drone was a dead drone. The threat was over. They were preparing to relocate to a secondary position, a standard procedure to avoid counter-battery fire and reduce vulnerability to follow-up strikes. But they were 90 seconds too late. The drone's onboard clock ticked past the 4-minute mark. At this point, the inertial navigation system had accumulated a drift error of approximately 8 meters, well within the kill radius of the warhead it carried. The terrain-matching algorithm had already corrected for most of this drift, continuously refining the flight path against known landmarks. The drone began its terminal dive, pitching downward at a steep angle, accelerating under gravity while its control surfaces made final adjustments. There was no warning sound, no incoming missile alert, no time to react. The impact registered on seismic sensors 12 kilometers away. The Krasuka 4, a system valued at approximately 300 million rubles, was struck directly on its antenna array by a drone that cost less than $50,000. The explosion tore through the electronics-packed cabin, shredding circuit boards, waveguides, and signal processors into fragments of scorched metal. The BAZ chassis buckled under the blast. Secondary fires ignited in the fuel tanks and the vehicle's onboard generator. Within 30 seconds, the entire system was engulfed, and 2 operators who had been outside the vehicle during the strike survived with injuries. The rest of the crew did not. 17 kilometers away, the Ukrainian command vehicle received no direct confirmation of the strike. Their data link was still jammed by the now destroyed system's residual emissions. But within minutes, a reconnaissance drone launched from a secondary unit arrived over the target area and transmitted back high-resolution thermal imagery. The screen in the command vehicle lit up with the unmistakable white-hot signature of a burning vehicle, surrounded by the scattered debris pattern consistent with a direct hit on a large mobile platform. The lead operator saved the image, tagged the mission log, and immediately began uploading the next target package to a second drone sitting on its launch rail outside. The war does not pause for celebration. What makes this engagement significant is not just the destruction of an expensive piece of Russian hardware. It is the strategic inversion it represents. For decades, electronic warfare has been understood as a defensive shield, a way to protect your forces by denying your enemy the ability to see, communicate, and strike with precision. Russia invested enormous resources into building this shield. It was supposed to make their positions untouchable, their logistics invisible, their command networks impenetrable. But Ukraine demonstrated something that will be studied in war colleges for the next 50 years, that the shield itself can become the target. The implications extend far beyond this single engagement. If electronic warfare systems can be reliably hunted and destroyed by autonomous drones that are immune to their jamming, then the entire calculus of electronic dominance shifts. The nation that spends the most on jamming is not necessarily the nation that controls the spectrum. It may simply be the nation that announces its positions most loudly. This is a conceptual revolution that challenges decades of military investment and procurement strategy across every major power on Earth. Every time a Russian electronic warfare system activates, it announces its presence to anyone with the sensors to listen. The more powerful the jammer, the louder the announcement. The more frequently it operates, the more data points Ukrainian intelligence collects. Position, capability, operating patterns, crew rotation schedules. The electronic warfare system designed to make Russian forces invisible was, paradoxically, the single most visible thing on the battlefield. And Ukraine built an entire kill chain around exploiting that paradox. The autonomous drone that delivered the strike was not a miracle of technology. It was a miracle of adaptation. Its components were largely commercial. Its software was written by engineers who, 3 years earlier, had been building mobile apps and cloud platforms. Its navigation system relied on principles that have existed since the 1960s. Inertial measurement, terrain contour matching, pre-programmed waypoint following. None of it was revolutionary in isolation. What was revolutionary was the speed at which it was integrated, tested, deployed, and refined in an active combat zone, under fire, with lives depending on every software update. While Russian electronic warfare doctrine remained anchored to assumptions developed in peacetime exercises, Ukrainian engineers were updating their drone firmware weekly, sometimes daily, in direct response to observed jamming techniques. This is the fundamental asymmetry that is reshaping modern warfare. It is not about who has the most expensive technology. It is about who can learn, adapt, and deploy faster. Russia spent billions developing electronic warfare systems optimized for a battlefield that no longer exists, a battlefield where drones depend on external signals, where jamming equals neutralization, and where electronic dominance guarantees protection. Ukraine spent a fraction of that amount building drones that simply do not care whether they are jammed. Drones that turn jamming into a homing signal. Drones that use the enemy's own defensive posture as a targeting mechanism. The cost ratio alone should terrify every defense planner on the planet. A $50,000 drone destroyed a 300 million ruble electronic warfare system. That is not a marginal advantage. That is an extinction-level economic equation for any military that relies on expensive, centralized platforms to dominate the battlefield. Every hour that Krasuka system was operational, it cost the Russian military thousands of dollars in fuel, maintenance, and crew support. Every hour the Ukrainian drone sat on its launch rail, it cost almost nothing. The mathematics of attrition have been inverted, and no amount of budget allocation can reverse a ratio that lopsided. The lesson is as old as warfare itself, addressed in the language of a new era. The fortress that never moves becomes the target that never escapes. The shield that glows the brightest draws the sharpest sword. And the army that adapts fastest does not need to be the army that spends the most. Somewhere in eastern Ukraine right now, another Krasuka 4 is powering up its antenna array, preparing to flood the sky with electromagnetic noise. Its crew believes they are protecting their position. They believe the wall of energy they project makes them safe. And somewhere nearby, in a frozen field or a concealed tree line, a drone is already in the air, waiting patiently for the signal to disappear. Because that is the only confirmation it needs that the target is exactly where it expected it to be. The jammer hums, the drone listens, and in the silence between them, the future of warfare has already been decided.